Sometimes you'll be expected to use the binomial theorem with such expressions where you have one of the terms having x in the denominator. So usually they are given with higher powers, and sometimes they don't expect you to expand the whole thing. They might just want one term. However, I want to do an example where we are expanding the whole thing just to discuss what happens with an x in the denominator. So it's not a bigger issue. You just have to make sure that you remember your rules of exponents, and then the rest should be fine. So when you have such an expression, you first want to rewrite it. We want to bring x squared to the numerator, but the way to do that is to change the positive power to a negative. So we reciprocate it and we get this. So now x is to the power of -2. Now, if x had a coefficient next to it, like 2, for example, like let's say there was a 2 in the denominator here as a coefficient, don't change the 2. You can keep this as 3/2. So when you're doing your binomial expansion here, the -3/2 would be one term that you'd raise to the power. So that's just for example. But only deal with the x. Only move x to the numerator, and by doing that you change the power to a negative. So the power becomes -2. Now we're going to follow the same exact procedure as the usual binomial theorem. The first term goes here and the second term goes here, remember, with the sign in front of it. We then follow the binomial theorem where the first term reduces in power, starting with 4 because we're expanding to the power of 4. And then the other one goes from 0 to 4, and I'm going to show how this can be done, but make sure everything is in a bracket and everything is correct. Also, the -2 only belongs to the x. So if you want to put a bracket in the -2 like I did here and continue with the brackets here, that's fine. The -2 does not belong to the -3. It only belongs to the x here. And then the binomial coefficient. Here is 0, 1, 2, 3, 4. So if I want to simplify it, this is what's going to happen. The first two columns you should know. The third column, you need to remember your the rules for expanding for indices. So you are spreading the power to each one. So the first one will always be 1. Anything to the power of 0 is 1. This will be as it is, so that's fine. What about the second one? You're raising the -3 to a power of 2. And you're raising the x to the power of -1 to the power of 2. So remember, you are multiplying the powers here. You're not adding them. So for the first one, it's going to be -3 squared. And keep the brackets. Keep the negative in the bracket. That's very important. And then I have a power of -2 and then squared. So what happens here, this will be equal to 9, a positive 9. And then this, you'll multiply the powers, so you end up with a -4. And that's what we have here. And you can repeat the same thing with the others. Try it on your own. Make sure that you're multiplying. So this will be to the power of 3, and this will also be to the power of 3, but you're multiplying these powers together. So I'm getting a -6. You're multiplying these powers together, so you're getting a -8, and you're raising the -3 to the power of those. So hopefully this is clear. Take it slow. Try to expand and remember your rules of indices here. So once we have that, also note the negative powers only happen, the negative coefficients only happen with the odd powers. That's something we've discussed in a previous video. So then to simplify, you're going to multiply the coefficients together and the powers together, but I do want to discuss the powers. So this is what it simplifies to, and notice that I did it in a bit of a longer method this time. Because what I did here was I did the 4 times -3, which is a -12. But then I took the powers and I just put them next to each other. So x cubed x to the power of -2. Now again, with the rules of indices, if you have the same power, if you have the same base, so we have the same base, you add the powers. It's different than here. This is multiplying the powers because, so if you have a, b to the power of n, it's going to be a and b, n. But if you have a to the power of n, and a to the power of m, if they have the same base and they're multiplying, then you add the powers together. So this is something you should know already. So we have x with the same base, so I can add the powers. So I have 3 plus a -3 plus a -2, that will give me a 1. So I have x to the power of 1 here. I'll do the same thing here. 6 times 9 and that will give me 64. And then the powers as well. I have x to the power of 2, x to the power of negative 4. So x to the power of 2, x to the power of negative 4. So they have the same base, so I can add the powers. 2 plus negative 4, that's going to give me a negative 2. So I'm left with a negative 2. And practice it with the others, you'll notice, I mean, there's only one. So 1 plus a negative 6, that's a negative 5. And then the last one is just the last term. So do replay this part if you need to, but it's not as complicated. I'm speaking quickly, but it's basically just the rules of indices, something you've seen before. So do revise the rules of indices if you're feeling a bit confused, and then come back to this and see that it's actually not that bad. It's just a matter of making sure that you simplify correctly. So once we have that, I'm just going to put it in the correct expansion here. Don't forget, don't just leave it here. Make sure you put it in the equation. And also note that, everything has a pattern. This was a pattern, the rules that we're using. Also notice the reduction in the power of x also has a pattern. So every time we're moving down, we're reducing by a power of 3. So 4, and then we reduce by a power of 3, we reduce, or you can look here, we reduce by a power of 3 every single time. Also, I changed the negative exponent and I undid, so basically going back to this part. So I had x to the power of negative 2, but I wrote it as divided by x squared. I had x to the power of negative 5, but I wrote it as divided by x to the power of 5. I had x to the power of negative 8, but I wrote it divided by x to the power of positive 8. So you can change them back into this, or you can keep them as negative exponents. They're both correct, so you shouldn't be deducted on either form as long as your numbers are correct. So it's the same procedure for x in the denominator. You just need to make sure that from the beginning, your first step has to be to bring x to the numerator, change the power to a negative, and then deal with the same procedure. Just make sure you use the correct powers of indices. Also, I intentionally used an example where there's an x in the first term and an x in the second term because they simplify each other. Sometimes you only have x in the second term, so you don't have to deal with the rules of indices here in the last step. But I wanted to show an example where they're both together because it changes the outcome in the end. You still have to use the rules of indices.